Another type of question that you might see in relation to the functions and derivatives and the graphs of the derivatives are something like this. So finding the coordinates of the points on the curve of y equals x squared minus 5x plus 6 at which the tangent makes an angle of 45 degrees with the x-axis. So immediately that 45 degrees means our gradient is equal to 1. So we want to find out where that is. If we want to know when the gradient is equal to 1, obviously we're going to need our derivative. So if we've got y equals x squared minus 5x plus 6, the derivative of that is going to be 2x take away 5. Now we know that our gradient is 1 at that point, so we know that 1 is equal to 2x take 5. We can then add 5 over here, we get 6, and we get x is equal to 3. So we know the x coordinate of where that line is has a gradient of 1 is 3. And then if we want to know what the y coordinate is, we sub it back into our original equation. There's no point subbing it back into the derivative, which is what a lot of students will say to me, oh, can't I just put it back in here? Well, no, that's just going to tell you what the gradient is. It's not going to tell you what the y coordinate on the line is. So we're going to take it back here. So we're going to do 3 squared minus 5 times 3 plus 6. So we get 9 take away 15 plus 6. Now when I do 9 take away 15, I'm going to get my negative 6, and then I'll add 6 to that, so I get 0. So my coordinate is going to be 0. We can also be then asked, where is it parallel to the line y equals 3x plus 4? So that then takes it a little step further and says, well, if it's parallel to this line, then its gradient must also be the same as this line has, and its gradient is 3, therefore my gradient is 3. If it had said perpendicular, then that's where we would have done negative 1 over 3 and use that. So now we have a gradient of 3, so we go back to just like what we did here, where we found that our gradient was 1, and finding out what the x value is. This time we know our gradient is 3, so we're going to put that into our derivative. So we've got y dash equals 2x minus 5, and we know that that gradient is 3, so we're going to solve that. So add 3, we get 8 is equal to 2x, and then so my x must be equal to 4. Then I'm going to do that same thing again, where I'll sub it back into that original equation, which was y equals x squared minus 5x plus 6. And we're going to put in that value of 4. So I get 16 take away 20 plus 6. Now if I do 16 take away 20, I'm going to get negative 4 plus 6 is 2. So that coordinate is going to be 4, 2.